Welcome back to the course Mechanics of Solids. So, in the last lecture, we were just talking about how to analyze a mechanical system, right. So, what are the steps involved to analyze a mechanical system by following the laws of mechanics. So, first step was study of forces, as we have seen in the last class or the last lecture. Okay. Then the second step involves study of motion and deformation. That is, one is the cause, another one is the effect, and then finally we are trying to correlate or trying to establish a relation between the cause and the effect, that is application with some laws, okay, through some laws. So, application of laws relating the forces to the motion and deformation. Okay. So, these three steps we have discussed in the last lecture, which are required to analyze any mechanical system. Now, in this particular course, basically if you see the content, okay, or if you see the title of the course, basically we are talking about only the static part. That means we are not talking about any motion of the mechanical system. Suppose if I want to analyze a building, that is one static part. If I want to analyze a beam or column, all are static. If I want to analyze a particular machine which is not moving, okay, so these are static system, and we want to analyze those systems in this particular course. We are not talking about, or we are not interested to talk about the motion of the mechanical system, okay, when it is in motion. So, in this particular course we will be analyzing the system by following these steps. Like, first one is study of forces, then in the second step study of deformation, and in the third step we will be correlating, we will be establishing the relation between application of laws relating the forces to the deformation. So, in this particular course we will be following all those basic steps, all those three steps, but excluding the motion part. So, we are not talking about anything, any mechanical system which is in motion. Okay, understood? So, there is no problem, I hope. Well, so now when we are talking about these steps, now we need to know, when we are talking about, or when we are trying to study the forces involved in the system, then the obvious thing is that the first thing is that we should know what is force. So, you know what is force, but for the sake of completeness we will try to get the definition of force. So, force is nothing but a vector interaction, as you know. This is not the scalar thing, this is a vector, right. So, force is nothing but a vector interaction. Now, two principal effects the force can give. The first one is that it might tend to alter the motion of the systems involved. Okay. So, it can give two different effects. So, we will come to those effects right now. So, first effect could be, it might tend to alter the motion of the systems involved. Suppose you throw one ball, okay, in the upward direction. Now, what will happen? Now, you are not applying any force, but it will try to come down. Now, what force is causing this alteration of the movement? Because you are throwing the ball should go in the upward direction continuously, right, but it will not go, it will fall down. So, your gravitational force try to alter this motion, okay, your gravitational force will try to alter this motion of the ball. So, that is why the ball will actually or eventually coming down, okay. So, this is your alteration of the movement. The second effect, it might tend to deform the shape of the systems involved. So, what does it cause? It might tend to deform the shape of the systems involved. Okay. So, there are two effects, either it can alter the motion or it can deform the shape of the systems involved, right. Now, how you can think of that kind of deformation? Suppose from a wall you are hanging one spring and there is a mass attached at the bottom of the spring. Okay. Now, what you are doing? You are applying some force here. So, what will happen? The force F will try to stretch the spring out, right. That means, if you see the deformed shape, so this might be the deformed shape. So, this time the force is not altering the motion, because this is a static system, okay. Unless we are until we are talking about the oscillation of the spring, okay, this system is a static system, okay. So, this static system, when the mass was attached at the base, at the bottom, okay, of the spring, and then after that you are applying one force F, okay. So, when you are applying some force here, so that force will try to deform the shape of the spring. Now, you see this is not the exactly the same shape whatever you started with. So, this kind of deformation might happen due to the application of the force. So, the force will cause these two effects. One is alteration of the motion and the second is alteration in the deformation, okay, or the alteration in the shape, rather the deformation of shape, okay. So, now we should know few things about the force. So, we should know few things about the force. The first one is the magnitude of a force can be established in terms of a standardized experiment. So, these are the few points to be remembered when we are talking about the force. The first one is that how we will get the magnitude of the force. I am applying the force here, right. In this spring I am applying the force and this much of deformation is happening in the spring, okay. But how do I get the magnitude of force? How do I say that this much of force will cause this deformation? So, for that you need some standardized experiment, okay. The magnitude of a force can be established in terms of a standardized experiment. Like for this example, okay. So, this is a standardized, say, experiment. Now, if I say the spring is linear elastic spring and then the deformation of the spring will be proportional to the force, that you know, that as you increase the force, as long as, because these terms are not, I mean we are not supposed to say those terms because we are not equipped to say all those terms like linear, elastic and all those things, but however for the time being we are using these terms. Later on we will be seeing the actual meaning of these terms in a detailed manner. Okay. So now if I look at this spring, the spring, for that spring I am applying some force F. So if I apply say delta amount of force, so I will be expecting some delta amount of deformation. If I increase the force, deformation also will be increasing, right. So if I mean for example, if I apply 1 kg of load, okay, so I will be getting some say for example say 0.1 millimeter of deformation. Then if I increase 2 kg, that will be say some value of deformation, like that, right. So what we can say, what law is it is following, that F, that force is proportional to your deformation delta, right. So this is your nothing but your deformation. So this much is your deformation, okay. So originally it was here, now it has gone up to this position for the application of load F. Now F is proportional to delta, directly proportional to delta. So we can write F is equal to some constant, okay, some constant into delta, and this is known as spring constant. Right. So now this is, I mean if we consider this is a standardized experiment. Now if I know the spring constant, if I know the value of the spring constant, and from the experiment if I observe the value of delta, then basically we can quantify or we can establish the magnitude of the force F, isn't it? Yes or no, right? So in that way, for any mechanical system, if you want to quantify or want to establish the magnitude of the force F, then basically this is the way we will find out, okay. That means you see from this experiment. So what are the steps involved? We studied the force, we studied the deformation, and we established the relation between the force and the deformation, and then finally our job is done. So we have analyzed the complete mechanical system, we can say, right. So now the next point to be remembered when we are talking about the force, that is method of superposition. So method of superposition is valid till we are talking about the linear elastic system, okay. So method of superposition is valid. So what does it mean? That means that when suppose I have the spring, I have two masses attached, two different masses say, that is M1 say and that is M2 say, and this is giving me the force F1 and this is giving me the force F2, okay. So try to understand the system, mechanical system. I have one spring and this is attached with two different masses, mass M1 and mass M2, which are giving or which are imparting on the system by an amount of force F1 and F2. Now this is equivalent to another system made of the same spring where I am applying a single say mass which is nothing but m1 plus m2, that is the summation of these two individual masses, and which is causing a force F1 plus F2. Now, this system, whatever effect you will be getting, whatever response you will be getting from this system, the same response you will be getting from this system also. Okay? So, only thing is that instead of having two different or two individual masses, I am having only one mass, but the total magnitude of mass is same. In this case, it is m1 plus m2, and this case only single mass, and that is m1 plus m2, which is giving F1 plus F2 force. And here actually individual forces you are getting F1 and F2. So, the response of this system and response of this system will be same. The effect will be same, and this is known as method of superposition. That means, instead of having a single force or instead of having an individual force, you can switch over from this system to this system, or you can switch over from this system to this system. So, there is no problem at all. Okay. So, if we try to write down in sentence, so what is your method of superposition? So, we can write down like this: when two or more forces act simultaneously at one point, the effect is the same as if a single force equal to the vector sum of the individual forces were acting. So, what does it say? It says that when two or more forces like F1 and F2 act simultaneously. So, it has to act, I mean they have to act simultaneously, they have to be applied simultaneously. Okay? At one point, please try to understand, at one point, that means the point of application of that force, we will come to that point, one point of application of that force will be same. Okay. The effect is the same as if a single force, that is F1 plus F2, say that is single force F, okay, equal to the vector sum of the individual forces, vector sum of the individual forces F1 plus F2 were acting. Okay. So, this is known as method of superposition, and you will appreciate later on that this method is very, very handy and very, very helpful, okay, and very, very important to analyze the system when you are having very complicated system. So, you can say you have say n number of forces, okay, and if you think that if you consider n number of simultaneous force at the same time, okay, then basically your system may get complicated. So, what you can do, you can use or you can apply individual forces and you can get the response, and you can add the response together later on to get the total response obtained from the complete simultaneous force system, right. So, this method is known as method of superposition. We will use this method later on, and you will appreciate this method is very, very handy. Now, the third point is point of application of force, which is very, very important. Point of application of force. Now, in any system, if you consider, force can be applied at different locations, different points. So, based on that, basically you will be getting the different response. Okay. So, point of application is very, very important when you are studying the force. So, these are the things basically you should remember when you are analyzing the force, when you are studying the force. What was the first one? First one is that quantification of force. The second one is that method of superposition, that is valid for the force system, and the third one is the point of application of force, that you must know. So, what does it mean? Suppose this is a body, okay. Now, you are having different points, okay, and in these points basically, say these points are A, B, C and D, okay, and your force is applied at these points. Okay. So, this points of application of force is very, very important. Like suppose F1 is acting at point A, F2 is acting at point B, similarly F3 and F4. Now, for example, if you are thinking that whatever effect you are getting from this system, like the way the forces are acting on these points. Now, if you think, or if you say the F1 is acting at B, F2 is acting at C, and so on, if you just change the points of application of the forces, you will not be getting the same effect. So, points of applications, when you are studying the force, the point of application must be known, otherwise you will not be getting the same effect or the same response from the system. Okay. So, now we will talk about the next thing is that moment, that is another effect due to the application of force, that is called moment. Okay. So, if you look at this figure, in this figure this force F, in this figure this force F, okay, is acting along the line of action AB. This is the line of action, okay. Along that line of action this F is acting, and the point of application of this force is P. As we just saw on the board, that point of application is very, very important. So, the line of action is very important, and at the same time the point of application of the load is also important. So, this force F is acting on point point P, okay, along the line of action AB. Now, this O is another point on the space, whatever is shown here. So, on that particular space, the O is any arbitrary fixed points, okay. So, that point is fixed. Now, if I want to calculate the moment, the moment will be the vector cross product of, R vector and force vector. What is R vector? R vector is the displacement vector, okay. So, R vector is the displacement vector. If you look at this figure, this is your R. So, from O, this displacement vector between point O and P. So, now you understand the importance of the point of application. So, if you do not know the point of application, then basically your displacement vector cannot be established. So, once you know the point of application, then only you can establish the displacement vector. So, this point P and O, in between that, whatever displacement vector you are getting, that is nothing but your r. So, the vector cross product of displacement vector r and force vector F will give you the moment of force F, okay, and that will be acting normal to the plane, whatever plane we are showing here, normal to the plane, okay, and that will basically follow the right hand thumb rule. That means if this is the direction, so this is your direction, say if this is the plane on which the force is acting, the moment will be in this direction, okay. So, this is your right hand thumb rule. So, this is the direction of your moment. This will give you some rotation, the moment will give you the rotation, right, okay. Now, okay. So, from the vector algebra, if you recall your vector algebra from the mathematics, what we can write for this moment? So, moment, I can, if I want to find out the magnitude of moment, so basically I can write, so this is your r cross F, and the magnitude is nothing but magnitude of r, magnitude of F sin theta. What is theta? If you come back to this figure, this is your theta, right. So, this is the angle between r vector and your force vector. This is the angle between your r vector and force vector. So, this is your force vector, and if you extend this r vector, so this is your angle theta, okay. So, this will give you the magnitude of moment. Now, if you look at this, expression, okay, the moment of a force at a given point, so moment of a force at a given point, say at a given point means say O, the moment of a force F at a given point O, okay, is invariant under the operation of sliding the force along the line of action. What does it mean? Now, this force, this is the force vector along the line of action AB. Now, if you slide the force vector along the line AB, I mean from A to B, wherever you slide, and if you want to find out the moment with respect to point O, there is no problem, it will be always remaining same, because the force vector, the magnitude of force vector is not changing. What are the things are changing? The displacement vector and your angle between the displacement vector and the force vector. So, these two things are changing, and because of this change, you are, I mean, if both the things are changing, okay, and therefore, ultimately you will be getting this moment is same. So, as long as you slide the force along the same line of action with respect to some fixed point on the space, okay, you will be getting the same amount of moment. If it is so, then why should we not take some advantage of defining the displacement vector in such a way that we will be getting this thing very easily. Now, what we can get from here? So, moment of force, so moment of F about the fixed point O can be rewritten as force and then H and sin pi by 2. That means, we are defining the displacement vector in such a way that it will make an angle 90 degree between the displacement vector and the force vector, which is shown here. So, if you look at this figure, H is here. So, I am sliding the force, this force I am sliding say at this point. Now, this is my point of application. Now, this line will become the displacement vector, that is nothing but the perpendicular distance from O to the line of action AB, So, this H is coming here and the angle between H and the force vector F is nothing but the 90 degree, that is pi by 2. So, from this expression we can simply write the moment is equal to F H. Okay. So, what does it what does it mean actually? So, if you can manage to get the displacement vector in such a way that it will give the normal distance or the perpendicular distance from the fixed point to the line of action of the force, then basically your force multiplied by that perpendicular distance will give you the moment of that force with respect to that point, that fixed point O in the space. So, I will stop here today. Thank you very much. I hope that you have enjoyed the discussion on force and moments. So, in the next lecture we will be going or we will be talking about different concepts like equilibrium conditions, free body diagram and other important issues. Thank you very much.